Let's solve this exciting problem. So we have given this block diagram representation of one control system. Here we have two input, R1 and R2, and we have to find the output, and we have to find the C by R1 and we have to find the C by R2. So we have discussed earlier, to solve the problem which involves multiple input, we have to use the superposition principle. That is, we will find the output by taking into consideration one input at a time. So first we have to find the C by R1. Okay, assuming the R2 is 0. So as you can see here, if R2 is 0, then this point can be directly connected to this G3. So we can remove this summing amplifier here. So this block diagram will reduce to this new system. Then I have G2 here. Then I have this summing amplifier plus, minus. Then here we have a feedback H3. Then I can directly connect this to the G3, and here it is output C. Here we have H2 as a feedback. Here we have another feedback H1, which is going to this position. Okay, now we will try to reduce this block diagram. So by looking into this diagram, I have here G3, here I have here G2. So it looks like a feedback loop system, and we know its total transfer function will be like G3 1 plus H2 G3. But the problem is we have this takeoff point here. So we have to remove this takeoff point. So as you know, we have discussed in our rules to simplify this block diagram. If we have to move this takeoff point ahead of this block, G3 block, then we have to divide its value by the G3. Okay, because right now it is not getting multiplied by G3, and suppose if I will place this position before this G3, then it will get multiplied by G3. So to compensate that, I will place another block, or I will multiply this H3 by reciprocal of G3, that is 1 by G3. So now it will reduce to this point will come here, and its gain will become as 3 by G3, and this will become a feedback loop, which output will be G3 divided by 1 plus H2 into G3. Then as this point is here, and I have this block, a single block, and this block is in series, so I can multiply this G2 and this. So I will redraw this diagram here. So I have here plus, minus, this is G1, then this is plus, minus, then I have H3 here, H3 by G3, which is here, and I have this G3H2 feedback system. So its output will be G3 1 plus, because here it is minus, so I am writing here plus, so it will be H2 G3. And second thing is, as this thing and this thing is in series, so I can multiply both of them, so it will be G2 G3 1 plus H2 G3. Okay, and this one is a block diagram here, and I have here G2 function. Okay, no, not G2. I have taken this G2 here, so it is nothing, but I am just connecting this point here. G2 G3 1 plus H2 G3, and I have here H2 by G3. I have moved this takeoff point from here to here, and I have here output C, and I have here H2 block here, H2 block here, and no, not H2, this is H1, sorry, this is H1, which is going to this minus position. So we have reduced the system to this system. Now, as we can see here, this one is again a feedback loop, right? And it is a negative feedback loop. Okay, so I can make it a, suppose it is value is y, and that y will be equal to, y is equal to, this is a g and this is h. So our formula is g divided by, as it is negative here, 1 plus gh. So I can write here g2 g3 1 plus h2 g3 1 plus, then I have h3 g3, which is h here, and then multiply by g2 g3 and 1 plus h2 g3. Okay, so these two will be cancelled, g3 g3, and this 1 plus h2 g3 will go here, and this denominator will cancel. So I will left with g2 g3 1 plus h2 g3 plus g2 h3. So this is value of y, and this value of this is block. This can be replaced by a block, single block, which has gain of y. Now this y and g1 are in series, so we can multiply y and g1, so I will get y g1, and again I am getting here a positive feedback, negative feedback. So it will be like R1, then it is going to we have plus minus g1 into y. Okay, value of y is this, it's going here, this is C, and here it is h1, which is going to this position. So the output, the transfer function will be again g 1 plus g divided by 1 plus gh. So g is this and h is this. So the transfer function of this will be g1 y divided by 1 plus g1 y h1. Okay, now I will put the value of y from this equation to this equation. So it will be g1 y 1 plus g1 y h1, which is equal to g1 into y. Value of y is g2 g3 divided by 1 plus h2 g3 plus g2 h3 divided by 1 plus g1 h1, then value of y is g2 g3 divided by 1 plus h2 g3 plus G2H3. Okay, now I will take this term will go here and they will cancel out with each other, so it will be G1 G2 G3 and it will be 1 plus H2 G3 plus G2 H3. Okay, then I have G1 H1 G2 G3. Now we have to find C by R2. So here in this case R1 is 0 and R2 is present. So there is no such line here R1 and this point is connected to this point. So here H1 and G1 are in series. But please keep this thing in mind, here we have a negative sign. So when we multiply H1 by G1, we have to take consideration of this negative sign. So the combined gain of this H1 G1 will be the minus H1 G1. Okay. So we will take this one is first step, that we will remove this summing amplifier, multiply H1 by G1 with this negative sign, so it will be minus G1 H1. And second, what we can do here we have a block G2. So it is between these two summing amplifier. So what I can do, I can place this G2 block before this, behind this summing amplifier. So this G2 H1 and H1 will be in series. But the thing is, if I will place this G2 here, so this signal G1 anyways it has to get multiplied by G2, so it is getting multiplied before this position, so it is okay with G1, this signal. But the problem is with S3, because S3 signal here, this signal will come here after getting multiplied by S3, and here if it will find there is no G2 block is there, so there will be a loss of signal to this S3. So what we will do, we will multiply this S3 by G2. So what we have done here, we have placed this G2 behind the summing amplifier and we have multiplied this S3 by G2, and now we have these two summing amplifier and which are connected together. So now what we will do, we have unnecessary two summing amplifier and which are connected together. We will club these two summing amplifier and reduce to a simpler diagram. So let's do it. So here we have this slide. So it comes to be minus H1 G1 here. Here we have G2. Here we have S3 and we have here R2. This one is our input. So we are making this G2 here and we are multiplying it with this unit. So what I can do, I can make here this point as minus H1 G1 G2. So I will redraw it. So this one is minus sign here and this one is S3, so it is reduced to S3 G2, and I have placed this H2 here, so here it is plus sign here and we have here minus H1 G1 and G2. Okay, now these two summing amplifier are connected. This one is H2 and this is this S3G2 is coming from this point, and I have here plus and this one is plus, and I have here R2, and I have here G3 C, and this one is H2, and this one is here. Okay. Now in the next step, what we will do, we will club these two summing amplifier. So let's reduce it further. So we will make a common summing amplifier. Okay. Now this point is plus, this one is R2, this one is G3, this one is C. So this signal is coming here H2 as usual, is coming, this is H2, and this one is minus. Now I have another signal here whose gain is minus H1, G1 and G2. So it is going to here plus, and here it is also plus, so I can make it here plus. And I have another signal here S3 G2, here it is minus, so its equivalent diagram will be minus, and here the gain is S3 G2. S3G2. Now, as you can see here, we have a feedback loop. If you consider this thing, so we have here S3G2 as feedback, and here the multiplying factor is 1, the gain block is 1. So we can replace this with a single block diagram. So it will be like plus minus H1 G1 G2. Then I have here this, and this can be further reduced. This one is minus, this one is H2, this is coming here, this is G3, this one is C. So we will reduce this and this, so it will become G divided by 1 plus GH, where the value of G is 1 and where the value of H is S3 G2. So we will replace it with a block 1 divided by, as it is negative, we will write here positive, G2 H3 into 1. So it will be 1 plus G2 H3, which is going to the summing amplifier. This one is R2 and this one is plus, and this one is plus and this one is G3. Okay. Now let's try to further reduce this system. Now see, as we have discussed earlier, if the two blocks are in parallel, so they have a common point here and they are coming to the summing amplifier. So the point is, here they have a common point. So I can replace this summing amplifier and this system as H2, this is minus H1 G1 G2 minus, because this it has a minus sign, and then minus H2. So, and then after replacing this system, I have this block is in series, so I can multiply. Now looking into this diagram, we can see here these two blocks, that is this H2 block and this minus H1 G1 G2 are in parallel, and we have the summing amplifier here, so I can replace this summing amplifier and this block with a single block. So I will redraw it. So here it is a plus sign, so here the signal will be minus H1 G1 G2 and then minus H2, because here we have minus sign. Then this block will be in series with this block 1 plus G2H3. So as they are in series, we can take the product of these two blocks. So let's rename it as Q. So I am redrawing it. So it becomes minus H1 G1 G2 minus H2 into Q. Then I have again a summing amplifier here. I have my input R2 here, and here is another gain G3. Then I have output here. Okay, this we have removed. These two we have removed, and these two, this one. So I am connecting this line, this feedback. Now, as you can see here, basically this is an example of a positive feedback. For your clarity, I will redraw it, so the picture will become more clear. So it is plus sign here, and then it is G3 here, then it is C output, and it is coming back. This is plus, and value of this is minus H1 G1 G2 minus H2 into Q. So this is example of positive feedback, and we know how to replace the positive feedback. Its formula is G divided by 1 minus GH. So the equivalent transfer function will be G3 divided by 1 minus G3 into this H. This H is minus H1 G1 G2 minus H2 into Q. So here we have negative sign here, so they will cancel out with each other. So I will get G3 1 plus Q into G3, then H1 G1 G2 plus H2. Now what I will do, I will put the value of Q. So the value of Q is 1 plus G2H3. So it will be G3 divided by 1 plus Q is 1 plus G2H3 into G3, and then I have this term, that is H1 G1 G2 plus H2. Okay, now I will take this term into the numerator position here, and I will take this term here also. So it will be G3 1 plus G2H3, and then I have 1 plus G2H3 plus G3 H1 G1 G2 plus H2. So this is my transfer function for C by R2.